test that you'll take on Tuesday will have the problems jumbled up, and you'll have to know what to do when you see the different figures. So I really like this worksheet, and that's why I just decided we would do it again. And I don't think anybody will remember the answers because it's been so long now. Okay, so we're trying to decide if we're going to use Pythagorean theorem, special right triangle formulas, or trig. What do you think on number 1? Pythagorean theorem. As long as it's a right triangle and you know 2 of the 3 sides, Pythagorean theorem is the one you want to use. Which one's the C? X is the C because that's across from the right angle. So it would go what squared plus what squared is what squared?
6 squared plus 3 squared equals x squared.
Okay, so 6 squared plus 3 squared equals x squared. Since the 6 squared and 3 squared are on the same side, I can go ahead and square and add those up. What do you get if you square and add those up? Which is? 45. And then I can't leave the little squared there. How does he go away? I square root. No dividing, whoever said that. You square root, that's okay. And then does the square root of 45 come out pretty? Nope, so we're going to break it down. Okay, Jada, I heard you. What perfect square goes in there? 9. How many times? 5 times. And then 9, that one's a perfect square, so he comes out to be a pretty little 3, and then you can't take the square root of 5. And that's Mr. X. So that's a little refresher on Pythagorean theorem. And if you get an answer that you can break down, you want to break it down. Okay, number 2. What's that look like?
That would be trig.
This is trig. Very nice. Okay, if you don't remember, I have a lot of you talking. Please do not talk unless you're helping me. Before Christmas, I kept telling you, identify the hypotenuse first. Which one is it? X. X is the hypotenuse. It's across from the right angle. Then you go to the angle that's not the 90. And is 10 opposite that angle or adjacent to that angle? Opposite. Okay, this is when I look at the memory device SOHCAHTOA. Which one uses O and H? Sine. So I write the abbreviation for sine. Then you always put the angle that you're using, which is 32. Then you look at the memory device, and SOHCAHTOA, so has O and then H.
10 over x.
So 10 over x. Okay, at the time we were doing this, I told you there's 3 types of problems. This is the one I like the least. If x is ever in the denominator, he can't be down there. How do we pop him up?
You gotta divide by x. Or you gotta multiply by x.
I'm going to multiply by x. And x is understood to be over 1. And then if I multiply the right side by x, of course I have to multiply the left side by x. On the right-hand side, these little x's right here, they're going to cancel out, leaving the 10. On the on the left-hand side, I'm just going to drop this down. But I'm still not done because x is not by himself. What do you divide by? So we divide both sides by sine of 32. That's how we undo the smush, because x isn't by itself, and we're trying to solve for x. So to get x by itself, I have to make this go away. And since they're smushed together, they're multiplied. So to get rid of multiplication, we divide. The problem with the very beginning of the problem, Jada, was that the x was in the denominator, and he cannot be down there. So I multiply by him simply to get him out of the denominator, but then he's still not by himself, so you have to get rid of this by dividing by it. So like this cancels out, and then we'll put that in the calculator.
I know, I'm saying like the 32 is at the angle.
Yes, 32 is the angle.
Like what outside of it?
Well, you know how the memory device SOHCAHTOA, it has O and then H, so I put O over H.
I mean, I'm saying H, what is that? What's the hypotenuse?
Yeah, X is the hypotenuse. I'm not understanding your question, though.
Never mind. I don't know.
Okay. Let me know later. I can come back there and I can look at it. Okay. First period, we tried to get all the calculators in degrees, but you might want to check them because yours might not be in degrees. So you go to mode, and you just want to make sure that degree is highlighted. And then as long as it's highlighted, we're good to go. And then in the calculator, I'm going to put 10 divided by sine of 32. And what would you say to the tenths? 18.9. So x is about 18.9. Okay, good. What does number 3 look like? It's a special right. It's a 30, 60, 90 triangle. The reason I can't do Pythagorean theorem is you have to know 2 of the 3 sides. Okay, across from the 30, and I have it labeled up there in case you guys forgot. Across from the 30, you put a X. Now, if there's a number there, I told you to put an equals between it and the label. What goes across from the 60? X square root of 3. And what goes across from the 90?
2x.
Okay, every time you get done labeling, you need to know what X is. So if you know it, it's going to be easy. If you don't, you have to work harder. Do we know what X is?
8.
X is 8. So it's going to be an easier problem. If X is 8, what's this side down here? 8 square root of 3. And if X is 8, what's this? 16, because it'd be 2 times 8, and that'd be 16. Okay, then I have to be really careful when it asks what X is. What answer do you think they want? Yeah, that's right.
Oh, it's
Is it X equals 8, or is it 8 square root of 3? It's 8 square root of 3. So this up here, this X equals 8, was just us putting it there to help us with the problem. When they want to know what X is, they're talking about the original X in the problem, which we found to be 8 square root of 3. Okay, and then Y we just found to be 16. But yes, Travis, good job. They did want the right one. Okay, number 4. What kind of triangle do we have going on? 45, 45, 90, a special right. What do we label across from the 45? Just X. Across from the 45 is X. Can you guys stop talking back there?
We're just so happy that we just have to talk about this.
But you're being rude to me. What goes across from the other 45? X, and across from the 90? X square root of 2. All right. Every time you get done labeling, we always do the same thing. Do we know what X is? Okay, so this X will also be 3 square root of 2, so this problem's fairly easy. This X right here will also be 3 square root of 2. And then I just have to drop that square root of 2 that's already back there. Can you tell me what this is when you clean it up? 3 square root of 4, which would be
6.
Which would be 6. Isn't the square root of 4 just a 2? Remember, multiply by 2 of the same thing. Shoop, out he comes. Take the 3 times the 2 and you get a 6. Okay, so we found X to be 3 square root of 2 and we found Y to be 6. All right, what does Mr. 5 look like? Trig. Yep, it's trig. Okay, so here I go. Do I have a hypotenuse? Which one? 17 is the hypotenuse. Then you go to the angle that's not the 90. Jada. You go to the angle that's not the 90, and then is X opposite that angle or adjacent? Adjacent. Okay, memory device, SOHCAHTOA. Which one uses A and H?
T.
It's cosine
Times.
C-A-H.
Tangent.
See, we have an A and an H.
Oh.
So it's C.
I said it.
Yeah. So cosine, and then the angle, and then it's A and then H. So what over what?
X over 17.
X over 17. Okay, this is the kind that I like the most. X is on top, so it's not like the one we did up here. This one up here, X was on the bottom, so I had to multiply by them to pop them up. This one I like because X is on top. So all you do is get rid of division of 17. How do you get rid of division of 17? Multiply. So I multiply the right side by 17, which then means I have to multiply the left side by 17. The 17s on the right-hand side cancel, leaving X. And on the left-hand side, I just put that in the calculator. So in the calculator, I'm going to type in 17 cosine of 40. And what would you say to the tenths?
13.
13 or 13.0 if we give a number in the tenths location. So X is about 13.0. Okay, what does number 6 look like?
Trig.
It is trig as well. Do we have a hypotenuse?
Yeah.
We do. Which one?
20.
20 is the hypotenuse. And then I go to the angle that's not the 90, and it's 15 O or A? A. So what are we using? Same thing, cosine. So cosine of what? X equals 15 over 20. This is the one that's weird. Whenever x is an angle, that's when you're going to do the inverse. If x is a side, you're not going to do the inverse. But if x is an angle, you're going to do the inverse. The goal is to get this x by itself, and I can't divide by cosine because cosine doesn't have a number behind it. So to get rid of cosine, I do the inverse. So I'm just going to show you my work technically correct. So I'm going to multiply the left side by the inverse of cosine, which then means I have to multiply the right side by the inverse of cosine.
Why do you do the
To get x by itself, cosine has to disappear, and typically I undo multiplication with division, but because cosine doesn't have a number behind it, I can't actually divide by it. Like up here, when x was smushed with the sine of 32, I just divided by it, but the only reason I could do that was because sine had a number behind it. If you just have a sine, cosine, or tangent up against it, you can't divide by it. You have to do what's called the inverse. It's kind of strange. But taking cosine times its inverse just makes those go away, leaving just an x. And then this is all you put in the calculator. Does anybody remember how you put that in there?
Second cosine.
Second cosine. And then 15 over 20. What would you say to the tenths?
41.4.
Okay, and because this is an angle, I'm going to give it a degree symbol. Okay, so that's all three kinds of problems that you can come up with when you do the trig problems. If x is an angle, you'll do the inverse. If x is on top, like this one, you'll get rid of the division by multiplying by it. And this one, when x is in the denominator, you'll get rid of that by multiplying by x, and then, of course, you'll have one more step. Okay, I'm almost done bugging you. I want to do one more. Let's do number 8. It's a special right, so we're going to label. What do we put across from the 30?
You put AX.
Across from the 60? X square root of 3. Because there's a number there, make sure you put an equals. And a 2x. Okay, after you get done labeling, you need to know what x is. So let's look. Do we know x?
No.
Okay, since I do not know x, I need to solve this equation right here. So can you tell me how to do it? Divide by square root of 3 on both sides. And then you're going to foo-foo. Can you do it in your head?
I don't know. I forgot how to do it.
You did? Who can do it in their head? What is it?
That is square root of 3 over 3.
Okay, so I heard it. It's 4 square root of 3 over 3. For those of you who forgot how to foo-foo, you multiply by whatever's in the denominator over itself. This is our fancy form of 1. Foo-foo. And then 4 times square root of 3 is simply that, 4 square root of 3. And then square root of 3 times square root of 3 is square root of 9, but the square root of 9 is just a 3. Remember, multiply by 2 of the same thing. Shoop, out he comes. Okay, so that's Mr. X. That's what this guy up here is. So that's a 4 square root of 3 over 3. And then Y wants you to take 2 times X. So if you took this times 2, can you tell me what that would be?
8.
8.
Would be 8 or
Square
6?
root of 3 over 3.
Or would it be 16?
Over 6. Over 3.
Over 3. If you take it times 2, you multiply the 4 and the 2, which makes an 8. The square root of 3 just tags behind it. And then the denominators multiply to be 3. So it's 8 square root of 3 over 3. Okay? And then we already found the x, and we said that was 4 square root of 3 over 3. Do you feel like you remember how to do this? Okay. Now, tomorrow, I'm going to pass back your semester exams because we had some great semester exams and we had some not so great semester exams. And there was a lot of this stuff on the semester exam. So if you struggled with it then, I doubt that you got any better over Christmas. So that means today, would have been really important for some of you that maybe didn't do so well on the semester exam. Well, if you made a note card, you got 5 points extra credit on it.
Yeah, but like besides that.
Okay, so this is what I want you guys to work on now. You have about 15 minutes. I'd like you to try to knock out as much of it as you can. This is in your big packet. It's on page 49 of your big packet. This is the Unit 5 review. I'm not making this due until Monday. However, I don't want you to wait until the weekend to do it all. So I'm giving you 15 minutes now. I would like to see you working on it in this 15-minute time period. So I can come around and help you. You can help each other. and then that way you can just get a little bit done. So 1 and 3 you don't have to do, but I want you to do every other problem.
1 and 3, you don't?
Yep, 1 and 3 you don't have to do, but I want you to do every other problem that's on here. So 2 and then 4 through the end. So this isn't due until Monday, but you have a good 15 minutes now, so you can try to get a good chunk of it done. And then tomorrow, make sure you have your packet with you tomorrow, because tomorrow I'm teaching out of the packet.
The first page is homework.
No. None of it is homework for tonight. It's not going to be due until Monday. I would just like you to try to get some of it done now and a little bit later and a little bit later.